All right, so then, for your activator today, it says, in which table is y not a function of x? So let's review very quickly what is a function. A function is a relation, which is a set of ordered pairs, and you have one input to one output, which means you have one x value to one y value. Okay, so let's look at each of these tables and see where we've got one x value to one y value. And the most important thing is that x cannot repeat. All right, so on your sheets, if you look at your first table, you have 4, 6, 8, 4. And then we've got 4, 8, 6, 4 again. So if initially, as you look at this table, it looks like you have a repeating x because you have a 4 here and you have a 4 here. So x is repeating. However, if you look a little bit closer, this ordered pair is 4, 4, and this ordered pair is 4, 4. So in reality, what you just have is the ordered pair being repeated. So in this case, x is not really repeating. So this one, you would put yes for is a function. Okay. Now if I look at the next one, I have 3, 4, 3, 7, and then 6, 5, 6, 5. So if I initially look at it, yes, my x value of 3 is occurring 2 times. But if I make a closer look, that's the ordered pair 3, 6. This here is the ordered pair 3, 6. So really what I see is just that ordered pair being listed 2 times. So that means my x really is not repeating. So this one is going to be a function. Now, if I move over to the next one, I have 5, 4, 2, 1. And then I have all 6s over here. Now remember, which one can I not repeat? My x value cannot repeat. My y value can repeat as often as I want. So if I have here 5, 4, 2, 1, do I have a repeating x over here? No, I don't. So this one here is a function because x does not repeat. Y can repeat as many times as you want. So finally, 3, 4, 5, 5, and then 1, 8, 1, 8. So again, my 5 is repeating, but unlike the tables over here where the point is just occurring more than one time in the table, I have 5, 1, and 5, 8. So since these are repeating, and it's not an ordered pair that's just being repeated in the table, this one is not a function. All right, so let me zoom that in for you real quick so you can see a little bit better. And hopefully the explanation is satisfactory. We'll do more of these. Okay, so that's what it looks like. I'm going to pause the video real quick and get the next part of your lesson ready. All right, so what we're going to do next is we're going to review some of our rules of exponents. So if you did your assignment yesterday, you would have done this already. Well, let's review real quick what we already know about exponents. So if I have 2 exponents that have the same base, so for example, if I have 3 to the 6th times 3 to the 5th, what my rule or law of exponents says is that I'm going to keep my base and add the exponents. So if I were going to simplify this, 3 to the 6th times 3 to the 5th is going to equal 3 to the 11th. Okay? And that's what we call the power rule. Okay? Now, my next rule that I know is the quotient rule, which tells me if I have exponents with the same base, like 5 to the 8th divided by 5 to the 6th, that I simply keep the base and subtract my exponents. So 8 minus 6 gives me 5 to the 2nd power. All right? So these are the 2 rules that we already know and understand about exponents. The rule that we're going to learn today, and we kind of worked with it last week a little bit in a card sort that we did, but this particular rule is called the power of a product rule. Okay? power of a product. All right, and this primarily applies to what we call monomials. And you're going to learn more about monomials, binomials, and polynomials when you get into Math 1 next year. But for now, I'm just going to teach you what a monomial is. Okay? So if I take the following expression, let me get a different color here, which is going to be 5j to the 6th and I want to raise that entire expression to the 4th power, okay? What we did when we have like bases that are being multiplied, we added our exponents. When we have like bases that are being divided, we subtracted our exponents. So what we're going to do with something like this is we're simply going to distribute this exponent to everything on the inside of the parentheses. So when I distribute, that becomes 5 to the 4th. And when I distribute to the 6th, I'm going to keep the base of j, but this time, instead of adding or subtracting, I'm going to multiply. So 6 times 4 is going to be 24. Now, I know you might be looking at this and saying, wait a minute, but if you look at 5 to the 4th, okay, remember, there's always that 1 up there by itself. Whenever a number's by itself, it always has the 1. So this is really 1 times 4, which gives you the 5 to the 4th. All right, so you're still keeping the base and multiplying. So whenever I have a power to a power or a power of a product rule, I'm going to keep the base and I'm going to multiply my exponents. All right, so let's do another example to illustrate this. All right, if I have the monomial 11c to the 4th raised to the 3rd power, I'm going to do the same thing. I'm going to keep the base and multiply my exponents. So since I have that invisible 1 up there with the 11, 1 times 3 is going to be 3, so that's going to be 11 to the 3rd. And then c, 3 times 4 is going to give me c to the 12th. All right? And then you could further simplify this by going to your calculator and taking 11 to the 3rd power, which is going to be 1,331 c to the 12th. All right, so I keep the base and I multiply. Keep the base, multiply. Okay, so let's do another. Let's suppose that I have 2m to the 5th n to the 4th and all of that is going to be raised to the 6th power. All right, so we're going to do what I just taught you, is I'm going to keep each base, and I'm simply going to distribute this exponent to everything that's on the inside, keep the base, and multiply. So that's going to give me 2 to the 6th. So I keep the base of m, multiply 5 times 6, that gives me 30. Keep the base of n, multiply 6 times 4, that's going to give me n to the 24th. So then I could further simplify by 2 to the 6th power on my calculator, which gives me 64. So my answer would be 64 m to the 30th n to the 24th. All right, so let's do another. This is one of my favorite things to do in math. It's one of my favorite things to teach in math. Though some of you might be saying everything's your favorite thing to do and teach in math. Well, yes it is. So I have -3, and I'm going to have w to the 8th power, and then I'm going to have x to the 8th power, and all that's going to be raised to the 5th power. So I'm going to do the same thing. I'm going to keep my base. I'm going to distribute this exponent. I'm going to keep my base and multiply exponents. So that gives me -3 to the 5th, w to the 40th, and x to the 40th. Then I could further simplify on my calculator by doing -3 to the 5th power, and that would give me a -243 w to the 40th, x to the 40th. And that would be my answer. Okay? That would be my answer. So we'll do one more, and then after that I will set you on your own with the exercises. Additionally, I'm going to upload a video from Mashup Math that just goes over this entire thing again, and that way you can see it for yourselves, okay? So this one is going to be, we're going to have 4p to the 3rd, q to the 10th, all of that raised to the 6th power. All right, so same thing, I'm going to distribute this exponent to everything in parentheses. So I'm going to keep the base and multiply. So that becomes 4 to the 6th, e to the 18th, because 6 times 3 is 18, and then q, 6 times 10 is 60. All right, so then 4 raised to the 6 to further simplify is going to be 4,096 p to the 18th q to the 60th. Let me just zoom that out a tad bit. All right, so this is what you're going to be doing for your assignment. The power of a product with monomials, you're simply going to keep the base and multiply. And as you're keeping the base, these are how your answers ought to look. All right, so again, another math production brought to you by Mr. Gillard and the Pixel 4.